So in terms of adding telephony into Teams, I wanted to start with a little bit of a recap of where we've come from. So you remember Teams is an evolution of Skype for Business. So if we look back to Skype, there were three considerations that you had to take into account when you were adding telephony. First one was licensing, whether you were a standard, an enterprise, or a plus cal. And plus cal was the thing that gave you your telephony. That was anything to do with calling, you had to have a plus cal. Server roles. We had some choices around Standard Edition or Enterprise Edition. You had the choice around mediation servers, whether they were separate, whether they were co-located on with your front ends. And then you had some form of telephony interop. So that was either a SIP trunk direct into your Skype for Business servers, or it was some form of a gateway, or it was a SIP trunk to some form of compatible PBX, Cisco or what have you. And that was all nice and straightforward. You knew what was going to happen. So if you had a user in your office making a phone call, they were either on the Wi-Fi or they were on the LAN, that traffic went back to your Skype infrastructure and broke out to the PSTN. And you were pretty much in control of this portion of everything on this side. If the user was at home or at a remote location, you kind of lost a little bit of control where stuff was going over the internet. There were some things you could do to try and mitigate that and try and make sure it was as smooth a process as possible. And kind of what I'm going to cover on the team side is we're going to talk a little bit about the technical aspects. We're going to talk a little bit about the licensing aspects. We're going to talk a little bit about the networking stuff, so how you can kind of guarantee and manage the quality for some of these areas where you can. If we look at Skype for Business Online, you had three choices for how you bought telephony to that. You either took Microsoft as your carrier, and you could take numbers from various locations. You could bring your own trunks if you had Skype for Business configured in hybrid, so any of the telephony that you had in your on-prem environment, you could pipe that up to 365. Or you could take Cloud Connector Edition. Anybody have Cloud Connector Edition? Once. So CCE was Microsoft's first stab at what we've now got in Teams. So Cloud Connector was effectively a little virtual environment with 4 machines in it. There was a mediation server, there was a version of an Edge server, there was a version of an AD server, and you ran this, and it hooked into an SBC of some sort, and it spoke up to Office 365. Cloud Connector Edition was a nice idea. It just proved to be, reasonably impractical in the long term because you had this little bundle of servers that you had to have. You couldn't put it in if you had any form of Skype on-prem infrastructure at all. So where does that leave us for Teams? Two things that we're going to talk about for Teams Media. Meetings. Meetings is very straightforward. If you want to have audio in your meetings that's not PC to PC, you have to have a license and do that from Microsoft. You have to buy an audio conferencing license. It used to be that there were third-party conferencing providers integrated. Microsoft stopped selling that about 18 months ago, and then it dropped off the back end of last year that you had to migrate away from that. So Microsoft is your only choice. On the calling side, you've got two choices. You can either have Microsoft as the carrier, and you buy your numbers from them, or you port your numbers to them. And there's a little asterisk there. There are 2 locations around the world where that's slightly different. One is Australia. They have a relationship with Telstra. And the other one recently announced is Japan, where they have a relationship with a Japanese carrier. I forget who they are off the top of my head. And there's some catches there that your tenant has to be hosted in that region to be able to take advantage of that service. The other option is direct routing, and we all like direct routing. Anyone done direct routing? Kick CCE, right? Much, much easier to deal with. So what we're going to talk about a little bit later is how direct routing works, some of the things you need to think about for setting it up. And generally, you've got 2 choices for direct routing. You can either do it yourself, so any of the gateways that you've used with your Skype for Business infrastructure, you can take those and generally convert them to do direct routing, and they can do that in parallel. So you can have direct routing sitting alongside connectivity into Skype for Business or whatever else those SBCs are talking to. The other option is hosted. So there's an option that Microsoft has for direct routing where you can have a giant direct routing setup and host multiple customers on that. So you're finding quite a lot of the carriers or some of the managed service IT providers are spinning up their own direct routing hosted services. So let's take a slight detour to talk about licensing quickly. Generally speaking, you have your E1s, your E3s, your E5s, and you can see that for the core stuff, which is, chat, voice, video, webcasting, client access, all of those things are covered. The ones that are interesting for this telephony or media piece is the phone system add-on, the audio conferencing add-on, and the calling plan add-on. So phone system is the license that lets you do anything related to telephony. So even if you're having Microsoft as your carrier, you're having direct routing for bringing telephony in, be that hosted or bring your own, you need to have a phone system license attributed to a user to take advantage of that. But this is where E5 includes that license for you. If you want to have audio conferencing, that on E1 or E3 is a separate add-on, and again, it's included in E5. And then the last one, the one that isn't included in E5, is a calling plan. So calling plans are the things that give you minutes. So if you have Microsoft as your carrier, you need a calling plan to be able to do actual dialing to make and receive phone calls. If you have Microsoft as your carrier, there are only certain locations around the world where you can have that. I don't have Japan on this list, but that would be the same as Australia with an asterisk. Microsoft can natively do it in these locations here. For calling plans, there's a few things to be aware of. So calling plans generally, you either buy a domestic calling plan or you buy a domestic and international calling plan. If you're a large organization, you can slice that a little smaller. So Microsoft do offer small, medium, and large calling plan packages. By default, the domestic is a large and the domestic and international is a large. And that's just the number of minutes that you have. So small, 120, medium, 240, large, depending on your region. In the UK, it's 1,200. If you're in Americas, it's 3,000 minutes that you have. And then international is 600 minutes. So domestic and international is the large package plus 600 international minutes. The slightly tricky thing there is if you have users who all have the same type of calling plan license associated, those minutes will pool, okay? So if you have 10 users who have a domestic calling plan, you will have 10 times 1,200 minutes available across those users. But if you have 10 users with domestic and 10 users with domestic and international, you don't get 20 lots of domestic. You have 10 of domestic and 10 of domestic and international.
Is that still inbound and outbound minutes? So it's like, so you've got 20, 40 minutes, but that is 40 minutes inbound and then equals 40 minutes outbound?
Jason, as far as I'm aware, it's only in outbound minutes, isn't it?
Outbound minutes, only inbounds free of charge.
Yeah. There was something around the audio conferencing where dial out to local was initially in preview as included, and I don't think they've stopped that yet.
They're going to start using consumption credits on that.
Yeah. Porting. You can bring your numbers to Microsoft in these locations. Anybody done number porting? Anybody had problems with those number ports? Yeah, number porting is pretty notoriously bad. My experience, and I've done it 4 or 5 times to Microsoft, is their support is amazing for porting for some reason. I don't know who they've got running it, but good job. Because you fill in the form, you send it off, and what's supposed to happen is the form contains who the losing carrier is, who the winning carrier is. It goes to a clearinghouse. The clearinghouse says either yes or no. And if they say no, they don't generally tell you why they've said no. It's just no. And you will find out that it's because 3 years ago your company was acquired by another company and then Blue Yonder didn't adjust the address that was associated with the numbers and that actually your billing number isn't your primary number and blah, blah, blah. The ports I've done with Microsoft, they're not seamless, but when they say no, generally you will get a good idea about why that port hasn't been successful and you will get a reasonable amount of information back to help you work with it. If you are porting in numbers, you can choose for those to be allocated as either user numbers or service numbers. And same thing if you've got a calling plan, or even actually if you have a phone system license in your tenant, you can go online and you can choose to allocate yourself numbers to your tenant. When you're porting, user numbers are going to be the numbers that are going to go to users, and service numbers are the things that are going to sit behind call queues or auto attendants or as dial-in conferencing numbers. Okay, you can change that afterwards, but one of the nice things when you put a port request into Microsoft, When that port request is accepted, those numbers will appear in your tenant for you to use. So from that point, you can start allocating them to users. And when they dial outbound, it will present outbound that CLI. It will give that number out. But that means, obviously you won't be able to receive inbound until that port has gone through. If you need to reallocate those numbers and you haven't told them at the start, unfortunately Microsoft do remove them all from your tenant and then put them all back on. After the port and when Microsoft owns those numbers, they can toggle them for you without having to remove and reapply, but just be aware of that. It bears a little bit of planning up front if you want to. On the audio conferencing side, you can have dial-in numbers shared with other organizations in 70 plus countries around the world. You can choose to allocate more numbers to your tenant if you want to. So if you have a particularly big office in Newcastle in the UK and you don't want your dial-in conferencing number to be London, you can go into your tenant, say I want to pick a service number and pick Newcastle and have a service number and say that's my primary conferencing number. So you can assign them in different locations. And there's 400 or so cities around the world that you can pick to have numbers allocated to you from. You don't have to have calling plan licensing to be able to allocate numbers into your tenant, okay? So there's a ratio between the number of phone system licenses that you have and the number of service numbers that you can assign to your tenant. Because it might be that you're using direct routing, you don't have any calling plans, but you still want to be able to assign service numbers to do things with call queues or auto attendants, etc. So you can have service numbers without having a calling plan. The other one to be aware of is communications credits. So that should have been on the licensing slide, but a communications credit license is effectively you have in your tenant a pool of money, and you can set that to auto top itself up, or you just top it up when you need to. And anybody who then has a communications credit assigned to them can effectively do pay-as-you-go calling. So you remember that domestic and international? If you had a user who every month has to make one international call, you can still give them a domestic plan, give the communications credit and set it that they're allowed to make international calling, then that international call will come out of the communications credit pot of money. The other thing it's used for is if you want to have toll-free dialing conferencing numbers, so an 0800 number, you can, because you've got a calling plan license, pick to add to your tenant an 0800 number, but then anybody calling into that 0800 number, the cost for that comes out of your communications credit pot, okay? Generally, I'd advise, even if you don't think you're going to use communications credits, you probably want to get it enabled for your tenant and put $50 or something sat behind it so that it's there ready to go if you want to use it, as opposed to having to raise a ticket or go through licensing at the time. It can be quite a lengthy process to get that enabled and turned on. I don't think they do. I don't know. I haven't had any expire, but then I've never massively topped them up. Generally, you would put, like I say, put $50 and just let it roll as it needs to. Okay. So now we're going to take a slight detour into networking. And remember, those of you who were here in the Q&A yesterday, you promised to still be enthralled when I cover it today. Hello.
Just another quick question on numbers.
Yeah.
Non-geographical numbers, so 033 numbers or something like that. Can you get them through the team, through Microsoft?
Some of them you can, yes. Yeah, I don't think there's a list of specifically where and what, but
You can request them, and if you already own them, you can port them. So you can assign to a person, you can, as long as you own their number already, the answer is yes. If not, you can request them from Microsoft.
yeah. The other thing is when you go and allocate numbers to your users, what happens is you say, I want to add 10 user numbers to my tenant or 100 user numbers, and you pick which area or location you want them in. It will then come back with a big list. So it's gone and grabbed you more than you want, and then you pick a tick box to say, I want these. And again, some companies that we've done this with have got a little bit upset that the DDI ranges aren't contiguous, because it's, you've got a number here and a number there and a number there. You can put a support request in and say, I want a block of 100 numbers end to end, and Microsoft will try and go and find those for you and allocate them to your tenant if you need to. Okay, so networking. Office 365 data is generally stored in the location that your tenant was created in. This is less relevant for Teams, as we'll see, because Teams meetings can float around the world depending on who opens the meeting. But it's important that we understand this notion of having Azure front doors. So they're dotted around the world. It's quite hard to actually get a definitive list of where they are. It's not necessarily where there are Azure data centers themselves. And Azure Front Door is effectively a peering point or an access point, to the Microsoft network. And Microsoft want you to get from your internet connection, from your ISP, to the Azure Front Door as quickly as possible with as little interference as possible. And then it's their problem for how they get that around the world behind the scenes. As we said, there's 3 types of traffic categories. You've got optimize, allow, and default. The way Microsoft categorize that is optimize is high volume or latency sensitive information. It's stuff that's Microsoft owned and managed. They do provide the IPs, but again, generally if you can configure your firewall to use the URLs instead, the URLs will change less frequently than the IPs will. And I think it's fair to say Microsoft's starting to do a pretty good job at minimizing the amount of churn that you get on here and reducing the amount of ports that you have to have open. So for example, back in the Skype for Business days, you remember there was always a debate with a firewall person about a 50,000, 59,999 port range and whether that was good and whether that was bad or whether that's just tough, that's how it has to be. Things like on Teams, they've reduced that port range down massively. So you can have 3489 on UDP, there's like 3 or 4 UDP ports that you need now instead. And when we talk about transport relays, if you go look at the Microsoft documentation about transport relays, particularly in relation to gateways and media bypass, you'll see that there is still a giant port range that they require, but then there's a little asterisk that says in V2 or V6, it might be of transport relays, that port range will be slimming down. So, they're working to kind of compress some of this stuff. The other thing that they've had problems with, which is why things like the URLs or IPs might change, is in some parts of the world where Skype is blocked. Some of the team stuff, if you go and look at it, is making calls out to skype.com or something.skype.com. So they've had issues where stuff has been blocked or not allowed because those countries or those parts of the world don't allow Skype consumer, but that's having an impact on Skype Teams because Teams is using some of that infrastructure underneath. So again, some of these things will shift or change or update ever so slightly. On the optimized side, you can see here, it's pretty much do not touch that traffic. Get it out as quickly as you can. Don't do any SSL inspection. Don't have anything like Riverbed or Cisco WAN optimization if you can. Bypass your proxy servers and try and do local, external, or regional DNS lookups where you can. And generally all the stuff to do with Teams media, so stuff for meetings, stuff for calling, is going to be in that optimized category. If you have a look, that's what it will be classified as. Allow is things that aren't as sensitive, stuff that's slightly lower latency requirements, lower bandwidth. Same recommendations really, try not to interfere with it. And then default is stuff that just gets treated as normal internet traffic. Generally that is just going to be HTTP traffic of some description or another. To look at your network quality, there's 2 things that you need to do, or to look at your network's ability to support the type of traffic you might want to do with Teams. The first one is quality. So Microsoft provides a Microsoft networking assessment tool. It sends a tiny little audio clip out to a transport relay. That transport relay bounces it back to you over the internet, and then you get a little TSV file that you can analyze. There is I'll skip ahead and come back. There is a little command line interpreter tool there. So you can see here, out of those results, we did 3,625, we skipped 45, and then we got some metrics back here. And you get 2 types of metrics. One is if where you were testing was from the client, so the client to the Microsoft Edge, and the other is if you were going from the customer network edge. And you can see there's a slight discrepancies here, so particularly around latency. If you're going from the client, we would expect it has to be less than 100 milliseconds of latency. If we were going from the edge, we want it to be 60 milliseconds. That's to allow it from this one, there's an understanding that your client isn't in your data center, that there has to be an element of something happening while it's crossing over your WAN. If you chuck that through the tool, you will get a 90th percentile average of your metrics. So that is Microsoft is chopping out the bottom and top results from all those tests. And then you get a pass or a fail. So you can see here this one, it's called Skype for Business just because that's what they've got written in the tool. But packet loss rate, RTT, jitter, pass. If this was from the edge, we actually failed on the packet loss rate there. If you're running this tool, you need to just be a little bit careful. Ideally, you want to run the tool for as long as possible, right? Because the longer you run it, the better picture you have of performance over your working day, over your working week. If you run the tool and it stops and you restart it, it will overwrite the results, okay? So if you do that, you want to make sure that you copy the results out. Or from about 3 versions ago of the tool, I had a little PowerShell wrapper that you can find on my website. I'm in the process of trying to update that, so if you want it, hassle me and I will update it. But it's essentially a PowerShell wrapper that will run the tool, save out the results to another file, and then it just, instead of running the tool for 1,000 times, it runs the tool once, copies the result, runs it, copies the results, runs, copies it, and it just means it keeps running in the background. The nice thing with that is you can then, if I hop over here, I've built a little way of importing that into Power BI. So you can then start doing some nice things with it. So from here, I've got a little visual dashboard from this location where we ran the test. We can see down the bottom here, we ran 3,500-ish iterations of the tool. You get a nice view of what jitter was doing, and you can see, as you'd expect, from kind of 9 o'clock in the morning through till sort of 6 o'clock at night, there was an increase in jitter on the network. As people come in, they're doing their stuff. Some locations you'll see you get a massive spike, and then you get another massive spike at lunchtime, and that's when people are on the internet doing stuff in their quiet hours when they're not necessarily working. But then up the top here, we can then say, well, actually, for each of these statistics, what if we look at what the good metric is, what a warning metric is, and what a bad metric is? So bad is when we breach the Microsoft criteria, and warning is where we're halfway to breaching that. And that's just something, you can tweak that if you want to do. It's something I've built. And then you can see up the top here, by hour, how many numbers of calls we had that were good, how many that were maybe okay, and how many were a warning. And then down the bottom, we can still do things like work out what our 90th percentile is. But the other nice thing, if you do it yourself, is you can choose to say the invalid calls or not. So if I say I want to lock out all the invalid calls, this will now match exactly what the Microsoft tool is telling me my result was. But in my mind, the Microsoft Results Analyzer, it ditches any results that had more than 25 packets lost. I kind of want to know when there's more than 25 packets being lost, because that means something's not gone right. Yeah. I've made that in Power BI, and again, it's on my website if you want to steal it. It's also on TechNet Gallery. So on TechNet Gallery, Microsoft originally, the network assessment tool, it ran standalone. So you had to have a couple of things in the right directory as it, and you had to have the exe there, and then you would just run that tool. They updated it to be an installer file, and then it saved stuff into the local app data. I haven't updated my scripts to handle that new install method, but if you look on TechNet Gallery and search for Network Assessment Tool Plus, you will find a zip file that has an early version of the script, but also that Power BI and the tools, the scripts to take the TSV files into a format that Power BI can consume if you want to do it. This is my quick and dirty way of doing it with the Microsoft tool. There are third-party products from Nectar and one my org makes that will do this in a more organized way. So the second thing that you need to think about, as well as the quality, is your capacity. Because that's the two things, right? It's like, can our connection sustain the basic requirement that you need for real-time media, and then can it do it with enough capacity? Ideally, you want to combine the two of those things, but that can be quite hard to do. The network assessment tool, because it's only 18 seconds of audio, even if you run that lots and lots and lots of times side by side, it's not really going to be a true load test. Again, there are tools that will do true load testing if you want them to. But from a capacity point of view, you need to roughly plan or try and group your users into personas. And there's persona work that Jason might talk about when he gets to adoption personas.
No, I won't be discussing personas.
No, okay. So Jason won't be talking about personas this afternoon. But from a capacity point of view, you want to consider, is someone going to be doing audio? And are they going to be doing audio in a conference? Are they going to be doing video in a conference? Are they going to be doing desktop share in a conference? And it's more important whether they're going to be doing it or not than whether they're going to be doing it a lot or a little, because that will average out across your organization. But try and come up with buckets of, well, we've got this office, 80% of them are just going to do calling, maybe 10% are going to go calling and video, and 10% are going to do calling, video, and desktop share. That then means you can come up with a rough outline of how much bandwidth that might consume, and you can model that against what your network is and how much capacity you've got. As the chap yesterday pointed out, there used to be a bandwidth calculator available for Teams online as part of the My Advisor portal. That is moving into the Teams admin console, so that's moving into TAC. So you can model your organization in there. There's a few things that the capacity planner doesn't do very well, so stuff like if you've got direct routing and if you're using media bypass, some of those things aren't taken into consideration. So there is a little bit of skill to approximating what your setup is in the bandwidth calculator to kind of model the type of traffic you might want to see. Okay, so Teams media flows now. So this is talking about where traffic is going to go, roughly where the traffic is going to be point-to-point or via what kind of Microsoft service. 3 little icons to be aware of. We've got the icon for our Office 365 home tenant is located, an icon for where the Teams meeting services are located, and then there's these things called transport relays that we're going to talk about that, again, are dotted around the world that are used by Teams to do part of what it does. So starting out simply, if we have an internal user making a Teams call, we get the blue line, which is media, and that blue line goes from person to person. But our signaling is done via Office 365. So, this is that thing that obviously we need to have connectivity to the internet. We need to have those ports and protocols open to talk to Office 365 because that's where signaling and call setup is happening. And again, good old Skype for Business days, that stuff was all internal. But in Teams, it has to go out to come back. But media will attempt to negotiate direct between users. If we can't negotiate media direct, or if we've got an internal user and an external media, depending on the configuration of your firewall, even if a user is outside, it will attempt to negotiate media direct through your firewall where it can, and signaling again through the internet. If we can't negotiate media direct, we will use transport relays to relay that media for us, and we've got a slide a little later that talks about that. So our user sends media up to a transport relay, this user sends media to a transport relay, and the transport relays, you either negotiate that you're talking to the same transport relay and it just diverts the traffic, or transport relay to transport relay will happen in the middle there. So you talk up and across. I feel like a flight attendant. If you are doing multi-party calling or a meeting, it's the same behavior as Skype for Business. You remember when you used to be in a one-to-one call, you had a third person in, there was a slight dip and a pause, and then the thing came back. That's because behind the scenes, it was converting it into a meeting. And in a meeting scenario, everybody's media goes up to the Teams meetings service. And the Teams meetings service is then in control of gating who gets what content back. And this is where Teams, from the Skype days, but a little bit better, is it is doing some pretty neat things there to optimize who's getting what data. So if you're in a video conferencing call, you will be sending your audio stream to the server, you'll be sending your video stream to the server, and if you're doing desktop share, you'll be sending your desktop share to the server. But then if Steve is taking part in that meeting and he's on mobile, there's no point the meeting server sending him a 1080p video of me back down to his mobile phone. So the Teams meeting service is being in control of, well, that user is has only got the video in a small size, so I'm only going to send a small version of that video back down. Or I'm going to send, Steve's got it full screen, he's going to send the full frame, full bandwidth version of the video back down. So that Teams meeting service is doing some clever things to slice who gets what. Same as Skype. No. Yeah. Yeah, so it's slicing it two ways. It's slicing it by frame rate and it's slicing it by resolution. So it's like 7.5 frames, then 15, then 30, and then something P, 720p. If we are calling between Teams and Skype for Business, we have our signaling is doing this kind of weird thing where it's going up to the Teams service. The Teams service is talking across to the Skype for Business interop. That's then coming back down to the Skype Prem through hybrid and negotiating the call that way, but we do still get media between the two endpoints. So we still get media that is going locally. Direct routing. Direct routing up until a couple of months ago, a month and a half, something like that, had to do this crazy thing where even though your user was in the same location as your SBC, signaling same as before, but media had to negotiate through a Teams media processor to come back down to the SBC to then go out to the SIP trunk. That's how media went. It had to go outside your organization to come back in. If your users were outside, that was less of a problem because it was just bing and through. Fortunately, they've added media bypass, but media bypass as it stands at the moment still has a couple of catches, or a catch, or a big catch really, in that media bypass will give the internal user as one of their candidates the public IP address of the SBC that's been configured. So that will go to your edge firewall to then be hairpinned back in to the SBC. But you're still keeping it inside your network, you're just putting a little bit of extra load on that firewall. So you do need to look at whether that firewall can do it. The other thing that we haven't had it come up as an issue, but it's something I'm conscious of, is your SBC, when it sees this connection coming from a user that's on an internal subnet, generally that SBC has on its internal NIC a route for all your internal subnets. So you need to be a little bit careful that you're not going to have inbound traffic coming that way and return traffic kind of go that way. You might need to do reverse NATing on that firewall to mask the internal client IP. There is a thing coming at some point where using a version of location-based routing, you can define what your internal subnets are for your clients, and then when the Teams service sees that the client is on one of your internal networks, it will allow the SBC to provide an internal candidate for media as well. So that's when we will have true media bypass, in that an internal user will talk direct to the internal interface on the SBC in the same way that Skype used to be able to do. So this version of media bypass is a halfway house. It means that we don't have to have stuff going over the internet, but it is a little bit, just plan accordingly for it. Okay, so let's talk about Teams meetings. Teams meetings, unlike Skype for Business, happen in 3 locations around the world. There are 3 geo services for Teams meetings. There's one in the US, there's one in Europe, and there's one in Asia Pac. Not entirely sure which of the data centers it is, but they're spread around those parts of the world. What happens is that it doesn't matter where your user is located or where your tenant is located. It is the first user that joins a meeting. That meeting service nearest to that user will be the one that spins up and takes control of that meeting. So that's the one that's then in charge from that point on. So if I have a user, and this is where that local DNS and local internet breakout is really important, if my first user who opens the conference hits an Azure front door in the UK, they will then get directed to the Teams meeting service in Europe, and that will be the one that hosts the meeting. And the difference between these dotted and solid lines is the public internet, and the dashed lines is over the Microsoft backhaul. So this is your ideal scenario where, well, maybe not because we've got more users over on the Asia Pac side, but we've got our users in Asia Pac, they break out through their internet, talk to their local Azure front door, then get routed across the Microsoft backbone to that Teams meeting service, and that's the one that's hosting it for these users. If we had the other side, where our first user joined maybe from Australia, they talk to their Azure front door, Microsoft backhaul, and it's the Asia Pac meeting service that takes responsibility for that meeting. And then all our users on this part of the world talk via the short hop to the meeting service, and it's our UK user that comes back and over here. There's not much that you can do to control this. It used to be kind of in Skype days, if you had a real issue with where meetings were going to be hosted and you had pools in different parts of the world, you could have a service account that would create the meeting and that would be the one that opened it, or you train your users that if you had 20 people in one part of the world and one from the other, make sure it was someone who generated the meeting URL where there were the most users. With Teams, because it's this notion of who's first in, there's not quite such a way of being able to control it. I don't know what the roadmap for this sort of stuff is, but I would hope that at some point it might be possible that you would connect to your local Teams meeting service, and then there would be some sort of a barbell that Microsoft took care of to bridge those meeting services behind the gap. That's the sort of thing that I would hope would be a future roadmap type item. Important as well that how you find your local Azure front door is via an Anycast IP. So Anycast IPs are an IP range or an IP that is shared across multiple servers and multiple geographies around the world. So that's when your client says, I'm going to talk to the meeting service, you get given back an IP, you then, through routing, will be directed to the local entry point for that IP address. And that's how they find them. Also, just worth pointing out that that was for meetings, but if you've got a peer-to-peer call that isn't happening across your WAN, you remember that diagram that showed that they will negotiate via the Teams service, sometimes via these transport relays. The same kind of thing can happen here. So signaling still going back via your tenant, but then media will be user to transport relay to transport relay to user. So again, it will try and keep things local where it can. If you get stuff wrong or you've got centralized breakout, this is the sort of thing that you can see. So even if we've got our first user is joining on the Asia Pac side, if they're not doing local internet breakout or regional, it is possible that that will come out on the UK side, and this will then be the meeting service that is responsible. So you've got everybody going a lot further than they need to for the meeting. So again, it's not necessarily, doesn't necessarily mean they will have a bad experience, but it could contribute to that. So let's talk about transport relays. So transport relays are the Teams equivalent of the media relay that you used to have in Skype for Business. You do dynamic discovery to find your local relay. So when you log in to the Teams client, it will determine what's its transport relay that it's allowed to use. That means that at any point someone calls you or you join a meeting, you already know which transport relay you're going to start using if you have to. Privacy boundaries used to exist in Skype for Business Online. So there was this notion of, depending on where your home tenant was, you could only use certain transport relays. In Teams, anyone can use any transport relay. So even if we have a UK user with a UK geography selected against their Office 365 account and they go to Japan, they will still use a Japanese transport relay when they try and join a meeting. So it will always be local to the user, provided you've got all the internet and networking config stuff set up right. If you want to, there's a really good YouTube video. I think it's one of the Ignite sessions that I've stolen some content from shamelessly, with credit. But it's worth going and looking at that if you want a proper 400, 500 dive into that sort of stuff. When we establish a call, we use this thing called ICE with stun and turn, very similar to what Skype for Business did. Worth noting, if you are aware of ICE and how it works, when we're doing media bypass on SBCs, they can only use ICE Lite, which is one of the reasons we have a little bit of an issue around whether they have to have a public IP or a private IP, but we'll talk about that in a minute. The ICE stages, when we sign in, we get credentials so that we're allowed to talk to our transport relay, because again, this is Teams, same as Skype for Business, everything is encrypted, even our media that's getting put down on the wire. We will then do candidate discovery, candidate exchange. We will do connectivity checks, where the client, you will see them if you're doing a Wireshark or a network trace, you will see them trying to talk to each other on these different ports. They will then have media establish, and then they will do candidate promotion. The reason you need to do candidate promotion is the client, when it first sets up a call, will have a preferred client, and its preferred client should generally be its transport relay, because it knows it can talk to its transport relay, it knows whoever else is doing something can talk to their transport relay, and the transport relays know they can talk to each other. So even in that scenario where we have an internal user calling an internal user, you might see media initially going out to the internet via a transport relay, but then through this candidate promotion, they will decide that actually we can talk to each other on a better path, and they will swap media to that alternative path. Again, YouTube video there that explains this sort of stuff. So if we look at that in a one-to-one calling scenario, if I've got two Teams users and two transport relays, they will go and set up the call by getting a connection out to their transport relay, ideally on UDP 3478. They will attempt to talk directly to each other, and if that succeeds, great. If not, we will try and establish a connection to the opposite party's transport relay, because they'll have given me that as one of their candidates. Likewise, the other party will attempt to establish to my transport relay. If all of that fails, we know this user's talking to their transport relay, this user's talking to theirs, and those two transport relays will talk to each other. So this is part of that, Teams magic, it should just work no matter where you are, because there's this complicated stuff happening behind the scenes to try and work out who can talk to what where. Same sort of thing happens in conferencing, that we can use transport relays to talk back to the conferencing service. We don't do any sort of negotiation here, because we know that the server, the Teams meeting service, should always be able to talk to the Teams transport relays because they're both Microsoft, so they should always be able to talk to each other. But when we establish, we will talk to our transport relay will then go talk to our conferencing service, and in the meantime, we will also attempt to talk directly to the conferencing service to see if that is a better path, to see if that's a better route for wherever our users have ended up. Clear as mud? Perfect. So candidate promotion, the preferred candidate is only used initially. It is the candidate, well, potentially only used initially. It's the candidate that is most likely to succeed, which is why it is those transport relays. It's also what's used to establish early media. So you know that bit where you get the ring, 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 you pick up, you answer, and then you don't get silence. You generally hear the other person saying hello fairly quickly. That's what early media is taking care of. And then behind the scenes, we're doing this other stuff. The checks that it will do is it will check UDP versus TCP. The relays will also bridge between IPv4 and IPv6 if you need them to. They can bridge between TCP and UDP if you need to. And they will then promote candidates in this order. So it will prefer IPv4 over v6, it will prefer UDP over TCP, and it will prefer direct media over relay. So that's how it goes through and works out how to promote the different candidates until you have an optimal call. Okay, direct routing. So now we've done a whole 45 minutes worth of groundwork. I've got two really quick slides that talk about direct routing. So direct routing is where you take your SBC. This is assuming that you're doing it yourself. So you've got your SBC that is sitting in your data center or sitting in your office. It is hooked up to some sort of SIP vendor, ISDN, potentially, depending on the gateway, and you have it talking back to your users, and you have it talking out to the internet. To do direct routing, we need to have it talking to the internet because direct routing is effectively a SIP trunk to Office 365, okay? And the SBC is then sat in the middle dealing with routing calls between those services. What I don't have on this diagram is this SBC can also be talking to Skype for Business, it can also be talking to Avaya, to Cisco, to Mitel, whatever you've got. This is your voice router. Okay, so when you come to implement direct routing, you can do it, generally speaking, in a way that doesn't impact anything else that you've got going on in your environment, and you can then, through calling rules, dip your toe in and say, now I've got direct routing, I want to divert this number to direct routing instead of to the PBX, and you can start testing it that way. And you can also do things like, when a call comes back from Office 365, we can determine, is that part of our internal call range, divert it to whatever our internal PBX is, or send it out to the SIP trunk. So it's the same sort of stuff that you had in the Skype for Business days, right? That's the thing that lets you be clever about all of this stuff. So to be able to do direct routing, you need to have an SBC from these vendors. The primary three, I guess, being Ribbon Audio Codes and Oracle. This URL down the bottom here, if you search for planning direct routing, has an entire list that walks you through these things. So that has the SBC versions and SBC edition models and firmware versions that are supported for direct routing. You have to have some sort of internet connectivity for your SBC. And as I mentioned, because direct routing with media bypass uses ICE Lite, technically you have to have a public IP address direct on your SBC. The ICE Lite specification doesn't support being behind NAT. However, audio codes in their month or so old firmware will support doing direct routing with media bypass behind NAT because they manipulate the data coming out of the SBC. So they put the right IP addresses in for you. Ribbon, as of their 8.0.2 or 0.3 release, also support that now. They didn't, a few weeks or so back, so you had to have a public IP direct on, or you turn media bypass off. You have to have a public DNS name. So there has to be a certificate that is assigned to this SBC and a public DNS name that Office 365 will use to resolve back to that gateway. And this is where you might have a catch depending on how you've had Skype for Business set up, because in the past, we didn't care what certificate or what name was on that SBC as long as our Skype for Business infrastructure knew about it and talked to it. To be able to do this, generally you can only have one certificate and one name that you're addressing that gateway by. So it might be part of your preparation work that in your Skype infrastructure, you rename that SBC and you put a public certificate on it. And that's how Skype then addresses it. And then we can start hooking that up to 365 as well. Okay, so that's one little wrinkle to consider. Obviously, we have to have some sort of PSTN upstream, SIP PSTN, whatever it may be. And then for media bypass, we need to think about our network routing. So that's the thing I talked about before, where the client's coming at the SBC this way, and we want to make sure that the response doesn't come back this way. So you might need to talk to your networking team about maybe doing reverse NAT there. And also transport relays or internet. When you have media bypass enabled, the most common scenario I believe that you want that for is where you have internal users talking to that SBC. If you've got an internet user talking to the SBC, you have a choice. You either allow media bypass from anywhere on the internet through your firewall to the SBC, or you lock it down so that only the transport relays can talk to your SBC. At the moment, the Microsoft recommendation is you have transport relays are allowed to talk to the public internet of your SBC. So when you configure media bypass, the firewall rules you put in by default will be the media processors, which sit behind the transport relays. Media processors are the bits that actually do things like transcoding if they need to. Haven't done it enough times, haven't seen enough quality information to know whether it's better to do it to the internet or transport relays. Because the Microsoft guidelines is transport relays only, I would suggest if you're doing this, lock that public internet access down to just the transport relays and the media processors. You can then look at the quality, look at how it's going, and open that out to the internet if you want to. On the Office 365 side, there are 3 things that you need to do. First one is create the actual SBC object, and you need to pick a port that you're doing. Generally, I think we've been using 5068 because that isn't generally in use in the other organizations in their Skype infrastructure. You have a little Boolean to set whether you've got media bypass enabled or disabled, and you can create that gateway object with media bypass disabled, test that everything's working, flip that switch, wait a week, wait up to 24 hours, and then test if that media bypass is working. And the way you would test it is when you have a client making a call through direct routing, if you look in a trace of their traffic, you should see the SRTP data going to the public IP address of the gateway, and that's when you know the media bypass is on. Even if you see a tiny bit of data going to the public IP, but not the actual media, that means your client has been given that as a candidate and it has attempted to talk to it. If it's then not talking to it, then you know you've got firewall issues or some sort of routing issue. But the fact that you can see it's going to that IP means the client's been given it as a candidate, which means the media bypass config has applied on the 365 side at least. The other thing you can do is set a capacity counter. That capacity counter doesn't do anything other than alert you in the Teams admin console, the TAC, if you go over that capacity or you breach it. So when you configure a gateway, you can say it has a capacity of 50. That doesn't mean the 51st call will be blocked. Teams will still try and route a call to it, but it means that you can see in the admin console if you've gone over your capacity for that gateway. When you've got the SBCs created, you will see a little mini dashboard. In TAC, it will give you a rough idea, what level of concurrency you've got, your network effectiveness over a week, 30 days or 60 days, some of the network parameters so you can keep an eye on what your jitter, your latency, and your packet loss is. The stuff Jason's going to talk about in CQD, we'll let you look at that in a little bit more detail about trending what your users are doing, what the call quality for your users is like. We're getting there. Voice workflows, call queues, auto attendants. Call queues and auto attendants are the online versions of response groups. So if you're doing stuff with telephony, chances are you need to have some call queues or auto attendants to meet kind of a reception type scenario or something else. They are slightly different to the functionality that you used to have in response groups. The good news is that the UI for building them is very nice, actually. If you're doing it through the Teams admin console, it's quite nice and straightforward. You create a resource account, and we talked about this a bit yesterday. The resource account is the object that has the phone number associated with it. There is now a free license for that resource account, unless it's doing calling, and then it has to have a calling plan license assigned to it. Good news is that as well, it is supported for that resource account to have a direct routing number assigned to it. But you can't then have agents who are Skype for Business Online agents in a call queue if you're doing direct routing, because at the moment direct routing is for Teams, so you have to have your agents as Teams users. But then you're in a catch-22 because it's not an admin console for Teams and stuff and consulting talk. If you have a call queue, generally this is the process that you go through. You have a greeting, so you upload a recording or read some text out. You can play music on hold. This is the same as in response groups, so you know you've hit a response group because it starts playing music at you immediately until someone answers the call. A little trick I used to like to use is if you upload music on hold as the ringtone for whatever country that call queue is in, then the user doesn't hear music on hold and know that they're waiting, they just hear that it is ringing. So it's quite, it's a bit of a nicer user experience. They don't get ring, ring, playing Brahms, and then someone picks up. It just rings, 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 rings. Agent groups. Agents have to be online with a phone system license, but you can pick either an Office 365 group, a security group, or a distribution list. So that makes it a little bit easier for managing membership of those things that you can have a group bubbled up into one of these things. You can then pick how you want to route calls. So attendant mode is where all agents will get the call. Serial routing is it will ring through in order in that group, but unfortunately you can't adjust the order, so whoever is first in that group will always be the first person that receives the call. Or you've got round robin, where it will balance who it's sending the call to out of that group. Opt-out, you can, similar to response groups, allow agents to toggle themselves in and out of being able to receive calls. So there's a website that they go to, they tick a little toggle box, and that pushes them in or out of the queue. Agent alerting is how long it tries before it tries the next agent. Then call overflow is what happens when we hit the limit for that call queue. And then we have auto attendance. I would imagine that most people who did response groups probably didn't do a huge amount of stuff with auto attendance because you could do it in response groups what you needed, things like in-hours, out-of-hours, holidays. On call queues online, they don't have a notion of in-hours or out-of-hours or holidays or not holidays. So what you usually do is the auto-attendant is actually the thing that answers the call because an auto-attendant does allow you to specify in-hours and out-of-hours and holidays. And then you can say, during my business hours, route it to my sub-call queue. Out of hours, leave this message or divert it to a user to take a voicemail, okay? So generally, where you might have had one RGS workflow, you might need to have an auto-attendant and a queue to replicate that same functionality. You can also do the stuff where you can do dial by name. So, I want to speak to Jason or whoever it is, and it will go search the directory for it. Voice routing with direct routing. Dial plans. You'll be familiar with dial plans from the Skype for Business days. Dial plan is what is responsible for taking the number that a person types into the dial pad or clicks on a tel URI, and it normalizes it. So generally, you want to normalize it into E164. So E164 is the international standard for dialing, so plus country code number. So if we've put a 0, we've got a rule that will drop the 0 and put a +44 on, okay? Usually you will then use the SBC to convert that back down if you need to. If your SBC is talking to a SIP provider, chances are they will expect and want you to send them E164 numbers, so great, the dial plan takes care of it. Where you have an ISDN trunk hooked into your SBC, you will probably have to have rules that will say drop the +44 and put a 0 back on the front of it. So that can seem a little bit counterintuitive, but at least it means this way everything that's happening in your Teams environment, same as your Skype environment, is in E164, and then you deal on the edges of converting that back out to whatever format you need. Good news with dial plans is Microsoft does provide country-level dial plans by default. So if I have a user that has a calling plan assigned to the UK, it will take care of things like that, dropping the 0 and putting a +44 on. So it will take care of how to dial an international number, it will take care of how to dial a national number, and it will take care of how to dial non-geos. What it won't do is things like local numbers. So it won't know if I still dial a local number, which locality I'm in to then blow that up to be the full number. So that's where you can create tenant-level dial plans, okay? So you can create your own rules. You can have 25 rules in a dial plan assigned to a user. And this is where you get funky with your regex. So you can do stuff like, if a user's dialed 6789, turn that into blah, 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 6789. Or maybe your help desk. You've got people dial 333 for the help desk. Take 333 and blow that up to be whatever the number of our help desk is. So you can create those rules to do that in your dial plan. The other thing that you have to assign to your user is a voice routing policy. So voice routing policy is the thing that acts as signposts for how users are actually going to make calls when they place one. So VRP contains a PSTN-U, and a PSTN-U contains a VR, a voice route, okay? So you remember the good old triangle that you used to have in Skype for Business days if you had these things and PSTN usages kind of glued everything together. The way it works is your voice routing policy is the one thing that is assigned to a user. A voice routing policy contains a PSTN usage or more than one PSTN usage, and a PSTN usage contains a voice route. And you can assign number patterns against your voice route to say this voice route is only allowed to accept numbers for numbers that look like this pattern, or you can do .* and they accept all calls. And a voice route can contain more than one SBC, okay? So it will also do kind of a loose round robining. So if you have one voice route containing 2 SBCs, call 1 will go to SBC1, call 2 will go to SBC2. If SBC2 is not available, everything will go to SBC1 until SBC2 is back up. But you can then build these things up to do different scenarios if you want to. So from a basic point of view, you can have a VRP containing a PSTNU, containing a voice route, containing an SBC. Boom, everything's going to go to that SBC. And I haven't included them in here, but on this voice route would be where you have regex to say what type of numbers dialed will go to that SBC. So a more advanced way of doing that, if we have active-active between 2 SBCs, we have our voice route with a PSTN usage with a voice route with 2 SBCs in, and that will then be active-active. So both those gateways will receive calls, and if one's unavailable, the other one will pick up the load. But maybe you want to have active-passive, in which case you have a VRP with a PSTNU and then 2 voice routes. And calls will only hit SBC B when SBC A is unavailable, assuming those voice routes have the same pattern assigned to them, okay? So it will be send everything to that one. If that one's not available, fall through to this one. And then you can start doing more advanced things if you want to with multiple PSTN usages. So we can have here SBC A, B, and B. B will only be used in this context for whatever this number rule set is if SBC A is available, but maybe to do with least cost routing or something else, there's a certain type of number that you want to only ever have go to SBC B. So you make sure that number pattern doesn't catch up here and it matches down here. So you can start doing some more advanced things with that if you want to. So you'll be relieved to hear that that's pretty much the end of this. I'm aware, and I'm sorry, this has been a little bit whistle-stop talking about networking and media and stuff to do with licensing. It's because telephony in Teams is quite a broad thing, but actually it bubbles down to something relatively straightforward. That you either take calling plans from Microsoft or you do direct routing. If you're doing direct routing, you can do hosted or you can roll your own. If you do roll your own, there's a few things that you need to go through to get it up and running, but it's not actually that complicated or that hard. If you do have SBCs and you're interested in experimenting with direct routing, go ahead and hook up a direct route trunk to your SBC at the moment. At most, it's going to be a little bit of network reconfig and it's going to be a public certificate that you need to buy for that gateway. But once you've got it there, you can, using the rules on that SBC, start diverting numbers up to 365 and starting to have a little experiment and a play around with it. Anything that you do with media with Teams is going to need a bit of planning and prep work. That's where, remember, we've got the quality and we've got the capacity elements. And Jason's talk, which will follow on, will cover how you look at the trending of the quality data. So it's really, really important that you don't just put this in and leave users to it. You want to be looking at, you remember the MOS scores from Sky for Business, so you could go in and you could have a look. CQD will let you trend what the jitter is, what the packet loss has been, so you can hopefully stay on top of any issues before they become too big. Direct routing is pretty nice. I quite like it. It is much simpler than CCE. Anybody who's done it here, hopefully you'll vouch that while it's got its flaws, particularly around media bypass at the moment, it's fairly robust, works pretty well, fairly straightforward. Your auto attendance and call queues, you need to plan and look at how those things hang together to mirror what functionality you might have had from response groups. And in some cases, there might need to be a little bit of discussion with the business about, well, this response group used to do this thing, or this hunt group was created for this reason. Actually, in a 365 world and Teams, is there a different way of doing some of those things? So you might need to reevaluate those. Yeah, that's it really. Any questions? Hello.